Okay, so hi everybody. This talk is about chasing bottlenecks. It's a little bit of an introductory talk, and it's a little bit of a sort of roundabout way to be able to see what the performance problems of your database are. A little bit more looking from the operating system side. And the description of the talk, it almost seems like it's misleadingly simple. Um, these tools like VMstat, IOstat, we all kind of know them, but there's just a wealth of information that you can get from them if you really start to use them quite heavily and rely on them. And sort of the way that you use them isn't always as straightforward. So in a roundabout way, I'm talking about the end goal is getting performance back in your application. The methodology doesn't necessarily sound as simple as it's advertised. And the basic methodology, of course, is we want to find out what the bottleneck is, then we want to fix the bottleneck, then we want to start again in this iterative sort of cycle. And it's misleading because in many ways, these tools, I'm still trying to understand where to get the value from them. A lot of talks skip over the simple items and they move on to things like looking in show InnoDB status or looking in show global variables. But these are just the bare root tools that can often indicate a lot of valuable information, and this is a good place to start. So I eventually get to that, but I just want to cover a few things before that. What I want to cover first is say that everybody's special. Your application is not necessarily the same as someone else's. Everybody has some quirks that makes it difficult to be able to just Google search and see what configuration items you can find to be able to make MySQL run faster. So we classify these differences in something we call a workload. And it's workload dependent in how we choose our optimizations to follow. So some examples of some common patterns that your workload may closely represent are things like data warehousing. Data warehousing is where we typically store large amounts of data, often a read-heavy load. We have some inserts, but it's typically assumed that it's not going to be a case that we're going to be updating or deleting data. Another workload that's quite common is OLTP. OLTP, we're sort of assuming that we have a mix of reads and writes. We have high concurrency, and we're usually making the assumption that a lot of our data or our working set that we're working with is fitting in memory. You can find benchmarks, and I'll get to that in a second, that sort of cover one of these two categories. Maybe you might find that you're somewhere in between. Some other common patterns, you might find that you have a heavy write load where you're just writing a lot of data. This isn't too common, and this is one that's actually a fun one to optimize. But this really affects your strategy and how you work. OLTP might be another one. This is one I don't think MySQL is actually too good at, where you might have some reporting style queries where the queries themselves are very ugly and very complex. But the saving grace is that your concurrency is far less, so hopefully you can put up with it. So my tangent on benchmarks here is that sometimes if you want to know what sort of performance your system can get, you can try and run an industry benchmark. And Sysbench is very nice at having these built-in tests, where it might be OLTP or data warehousing, to know that your physical database server, the way that you've set it up, can do 5,000 transactions per second or something like that. These are good for A/B testing, to sort of know if a configuration item like ODirect works well in your system. They're not necessarily good as a definitive resource, of course, because your workload is different. So, chasing bottlenecks. What do I mean by this? It should even be an adjustment to that. It's chasing the bottleneck. And sort of by definition, you're only really concerned with the most prominent problem that you have at this one point in time. When you fix that, then you can move on to the next problem, because that one problem is where the best value for money can be found in improving things. And your tools of the trade often come from your operating system, with some other ones just below that come from MySQL. So I'm talking about things like VMstat, IOstat, free, top, SAR and MP stat. I actually don't know these ones as well, so if there's anyone in the crowd that wants to provide input on them, happy to know. And then some things from MySQL like show process list, show NODB status, and show global status helps as well. I've just omitted that from my slide. So starting with one of those examples, let's look at uptime. What can I read from uptime? Common for a lot of Unixes. In uptime, we can see how long the server has been running. We can see the load average that the server reports. And this number sort of just shows a backlog of CPU-bound tasks. So if we have one CPU, anything under one is sitting pretty happy. If we have multiple CPUs, anything sitting lower than the multiple of CPUs that we have is probably good. Gets a little bit complicated because not everything can be divided among CPUs equally. So I don't know if I'd like to be completely hovering around at 16 if I had 16 CPUs.
Well, the thing about load average is that it's not really load as you think about it, right? It's the
Yep.
number, it's the average number of processes that are waiting
Yep.
at any one given point in time. Which, you know, with MySQL, you can have a lot of things waiting, and that's not necessarily a bad thing. So sometimes, like, I've had complaints where, you know, people have, like, you know, an 8-core server, and the system is like, oh my god, loads at 2.
Yep.
Because and that's like the constant load average is 2, but that's just the way, you know, so MySQL kind of has some kind of weird things. So you always have to get a baseline, right? Because if your baseline is 2, then that's, you know, it's not a big deal if you go up to 4, right? But if your baseline is 0 and you go up to 4, if your baseline is
Yep.
0.5 and you go up to 4, that's a huge deal. So I think it also helps to remember what load average actually is.
Sure.
It's not really like how heavily loaded, because people are taught that if it's anything over 1, it means your server is really loaded. But what it really means is that there's an average of more than one process waiting at any one given time,
Yep.
which is usually not so bad.
Yeah, you're helping me for a great segue, and thank you very
Okay.
much. What's probably more important in this case is when you do exceed your baseline and you get into a problem called context switching, where you have to juggle tasks by swapping one out to start another one. And the analogy for context switching is a little bit's okay, because there might be cases where you're waiting on a disk or something like that. But a lot of it's bad. And the analogy for that is that if it takes one person 60 seconds to dig a hole, does that mean that it takes 60 people 1 second to dig that same hole? There's some overhead from unloading something and then reloading to be able to work on that. If that worker is maybe taking a 5-minute break to get a coffee, like if we're waiting on a disk, then that's not a problem. There's a point where it really starts to hurt. And that's context switching. So that shows up in a later command that I'll get to. But uptime, I kind of use it. It doesn't give much information, but I use it as the first command that I issue when I connect to the server, just to give me a case of what we're dealing with. And then it helps me form some sort of speculation, which is how I proceed in my performance tuning. So from uptime, another one that's very speculative that I use is free. And I use it with free-m, just to give me a megabyte summary. And why I like this one, and it doesn't reveal much information, but it's enough to really get me started, is these first 2 lines. I like to see how much memory I have installed in my server, about 4 gig. How much of this memory have I used? Almost all of it. But where has this memory gone? And I can see that a large amount of it has gone to some sort of internal cache, most likely the file system cache. So if I'm using something like MyISAM, or even my binary logs that don't have a cache to be able to serve them to slaves, I depend on a certain amount to be used up by this cache. I don't want this to ever go free, but I don't want it to be excessive either, because I want to make sure that MySQL has some buffers and caches being used where it can. But then if I look down at the next line shows me this same information if I weren't taking into account the caches in this last column here. So of my 4 gig, I've used 2.3 gig, and I have 1.7 gig free. So, you know, I'd have to assess this with the time of day that I'm looking at my server. Maybe I could allocate a little bit more on the MySQL side and less to the file system caches, but I'm at least happy that I'm using half my memory. and it would depend how much MyISAM I'm using versus maybe another storage engine. In this case, I used a lot of MyISAM, and I loved that this could be used to serve MyISAM data, which doesn't have its own cache. So the swap line I don't look too much into. I have a better way of finding this information, but I can see if we've used any swap. Any questions with that one? So it's a quick one, but I love it. Yeah.
I usually just do, is free available, what is it, on Linux or?
It's Linux, yep. I don't think it's part of any standards.
Yeah, because I know I usually like cat proc meminfo,
yep.
because that's usually on.
And you can get the exact same information.
Except
yep.
it's in bytes, not megabytes, so this,
yep.
this is more useful. But
you can do this in gigabytes as well if you've got more money than my own server had.
Is it, but would it give you like 4 gigabytes or would it give you like 4.0? What's the precision on that?
I don't know what the precision is. I don't think it has any precision at all.
Right, so it'd just be 4.
Yep.
Which, you know, wouldn't really help
if you got 4.5 gig of memory.
Right.
Yep. Yep. Cat meminfo, prop meminfo would be the same information. Okay. And this is my command that I use to get that swap information. And I get some information about context switches from this one as well. vmstat is reasonably common. I don't believe that you have to install the package called sysstat for this one. Maybe I might be wrong.
No,
I'm wrong?
It's not. You don't have to. This for
you don't have to?
IOstat you do, but not for
Yep.
vmstat.
So this one's pretty common to be installed. What do I like in this? I like this in that I can get trended information. Because the previous two that Uptime was more real-time information, but free is completely historical. This is getting into trended, what's happening now. So I would use this command on a server that I'm logged into at the point of the most load, because I want to know what bottleneck they're hitting. Maybe most of the time they're doing okay, but then they get into a situation where they start swapping. And I'm more interested in how much they're swapping right now than how much they've swapped over a long period of time. That's my bigger concern. So I'll often sit in vmstat, and it has a couple of parameters that you can send to vmstat. The first one I've got here is 2, which means give me 2-second averages. You can choose your aggregate. I'm happy with somewhere between 2 and 5. It would depend how many sharp peaks you have as to what you need to do to get good information. I'm saying just give me 5 of those and exit. Optionally, I could just not say that second argument and I'll just get a continuation of 2-second intervals. The men page will show you the finer points of that, so I won't spend too much time on it. So what do I look in vmstat? vmstat is my helper to see if I'm using swap. And I'm concerned about these 2 columns in swap, SI and SO, swap in and swap out. Swap in itself is not always a bad thing. What's the bad thing is that how much it's doing it every couple of seconds. I would rather my operating system swap out stuff that it's not going to be using too frequently than keep it in memory, which has that sort of price premium. So on a desktop application, often Linux is tuned in such a way that aggressive, memory-hungry applications will push those inactive pages out to disk, so that if another process comes along, it can give it real memory. And the swap in itself is not that issue. In a database, it's a little bit different, because in a database, we might have pages that are inactive, but we're depending on them being some sort of cache. So if the kernel starts swapping those out, we're a little bit worried. So you can configure that a little bit in Linux with something called swappiness. Tune that parameter, and hopefully you won't have that preventative nature of swapping. But swap's important. R is important. R is that run queue of tasks. Similar sort of information to what was in uptime, of tasks that are just waiting in that queue, waiting to be completed. Here it doesn't look like I was hitting too heavy load on my server, because I've got zeros in every column. I have a slide on my next slide which shows you a little bit of this information I'm summarizing here, but I'll keep it with this screen up to explain it. The first line of vmstat, when you use it, in this mode, ignore it. It's giving you sort of a historical aggregation of the time that the server's been up. So here we can see that even though I said that we weren't under very high load, we're probably historically in a trough, well, because the idle time over the whole aggregation is a little bit less. But I often just ignore that because it's too wide of a window. Maybe I could look at uptime and see how long the server's running, but it's not that helpful. I can look at how many blocks in and blocks out of sort of I/O operations I've done. I don't read that information from this command. I read it from the next one that I have along. So my real things from VMstat is the run queue. I look at how much swapping we're doing while we're watching this interval. Sometimes I'll look at the CPU usage here. I'll say how many context switches have we done, and really that's relative to that baseline that we're expecting. There's no real perfect measurement there. System time, time inside the kernel, idle time, user time, that would be time in MySQL, and wait. Wait shows the percentage of time that our I/O operations could not complete, or that our CPU operations could not complete because they were waiting on some sort of disk operation to complete. And if I see this column high, this is really what persuades me to start looking at I/O stat and analyzing this more. It's not 100% a definitive method in itself, because there are some scheduling mechanisms that are applied to make I/O optimal, but not necessarily as fast as possible. So here's that summary that I promised. If you grab my slides, that sort of covers the topics that I mentioned. Ignore the first row, run queue, look at swap, look at wait I/O, look at the CPU breakdown. Yeah, sure.
If you want to get an accurate number for when the context switching is read, correlate to a baseline, what's the baseline?
The baseline would be some sort of historical trend that you have. So you can extract a lot of this information and graph it. And if you notice that not only is your CPU time high, but your context switches are high, maybe you can assume that it's some sort of involuntary context switch where the kernel's decided to swap things out. And so
How do you know that number's better context switching?
when it's orders of magnitude different from what it currently is. So here's let's say that the server is not very busy now, and we're looking at about 1,400 context switches, and all of a sudden the server's busy. That could be times 10 quite easily, and then I start to suspect that it might be a problem. When it looks disproportionately larger than what it has been historically, that might indicate that I'm context switching heavy. But this SAR will show that information. I don't typically use SAR as much just by force of habits, but I know that information would be in there.
Yeah, man, SAR, it's pretty.
It's pretty useful?
SAR has tons of stuff in it. In fact, let me open it up on my Ubuntu server right now.
Sure, I'd be happy to turn this interactive if you have
It
some.
says no manual entry for SAR. I don't think I have SAR installed.
It comes
Yeah.
in systat.
It does. It
Yeah.
does. I don't have systat installed because when am I ever doing stats on my laptop?
Yeah,
You know what I mean? So, and for whatever reason, I'm not getting good. I'm not getting any internet here. So.
cool. Let's hold that for.
Another thing, swapping is, what's the number you set to reduce it?
Sure. So I kind of brought that up without explaining too well. So swapping in itself isn't the bad thing, and you can configure that policy. So there's not. I saw that there was a blog post a couple of weeks ago by someone at Pythian talking about swappiness.
Yes.
That was Jerry, wasn't it?
Jerry Narvaja, yeah, who used to work for MySQL.
I thought that was a good post on how it works. So swap not being a bad thing, but for databases being a bad thing, you might want to choose to influence Linux so that its decision to be able to keep a memory, an application page loaded in memory, has a higher threshold or a higher chance of happening than Linux deciding that that's rarely used, and so it would rather put a file system cache page in memory. So you can configure that because it doesn't make sense in a database to swap out an application page in order to be able to swap in a file system page. That just seems like a silly idea. So if you want to have Linux have more of a choice of favoring all applications over other internal caches, you can echo into proc VM swappiness the value 0. I think that's the definition. And that'll do it at runtime. If you want that to persist on restart, there's a file etc syscontrol, and then I think that's just vm.swappiness equals 0.
Do you ever enable large pages to avoid the swappiness?
Interesting question, yeah. I haven't tried it myself, but that's another way of doing it. So you can have, they call them, in Linux they're called huge mem pages or something like that.
Yeah.
Yep, and you can custom compile in ODB. I don't think it's on by default.
I think you just have to enable the option. It's the large pages in your MySQL D. I've
All
played
right.
around with it, but I've never seen anybody actually use it in production. I haven't seen a lot of discussion about it in MySQL.
Yeah, it's a common optimization in Oracle and Postgres to be able to stop pages being swapped out. But I know Harrison Fisk from MySQL support had a good blog post on it explaining how it works, things like that. But I haven't tried it myself for experience.
Right. There's also I think Jerry in Jerry's post there was a little bit about you don't necessarily want to completely disable swappiness.
Yeah.
Because there's going to become a point in time where Linux wants to swap, and so you know what I mean. I guess swappiness is the tendency to want to swap.
Right,
Yeah.
but if you just turn on large pages, you can ensure that your buffer pool, NOD buffer pool is not getting swapped out. And if you have enough extra memory, then you still have room for Linux to swap other stuff out, right?
Right, so
Yeah.
you have to make sure that you still have that memory and still have that room.
The real issue is that you want if you are going to reach that swapping point, you don't want to reach that point and then fall off a cliff in performance. So Linux tries to be a little bit smart by, let's say, somewhere after 50%. It's not really that, I'm going to pretend for the example. It tries to say, all right, you're not using this page and this page, so I'm going to push that down to disk. So if I do hit that cliff point, I've already got these things on disk, and I can just drop my references to there, and then I'll have memory free to continue. It doesn't want to hit that real hurdle point. So it's smart in its design, but it's counterintuitive for databases because they're really caches. Cool. So that's VMstat. IOstat. IOstat's where I start analyzing the I/O a little bit better and how my disks are doing. I'd pretty much do it regardless, but I get those hints from VMstat for now it's time to look here. The package is called sysstat, so on a Red Hat-based yum install sysstat. On a Debian-based apt-get install sysstat, it's the same name. So what extra information do I have in here that I find really helpful? I like to, at my first glance of this, look at the very last column. I like to see what percentage of utilization I have of each individual device. This shows what percentage of the time this device was not idle. So it had Sunlink in its queue at least. It's not definitive in that if you have some sort of RAID device that just shows up as one item, only one disk has to be busy in order to be utilized. But if I see this hovering close to 100%, it gives me some indication that I always have some backlog and I don't necessarily have breathing room. The arguments to IOstat, similar sort of thing with VMstat. I did -x for extended. I wanted a bit more information than default output is. And I said 1 second intervals, give me 2 of those. And I have to discard the first interval and really just look at the second one. Some other things that I look for here, that utilization was my first thing. I can look at how many sectors we've read and written to. Is it reads or writes that are my problem? the reads can sometimes come from a file system cache. The writes can sometimes go to an OS write buffer. So I have to understand my hardware a little bit better to understand how costly or not costly these operations are going to be. Sorry, if I didn't really clarify that here. If we see a read here, it's not come from a file system cache. It's come from our physical device. But I know that, for example, I'm not getting a cache coverage on something like there, and I've had to read. If we have one of these OLTP style databases that I referred to, often reads might not be our problem because we can keep them in memory. Often we just see writes occurring instead. So this information, if I log into a system I haven't seen, it helps me build my strategy. It helps me understand the semantics of this database and how to proceed. So some other things in here that are quite nice. The await and the service time. The service time is the amount of time that it took to be able to service that request in milliseconds. The await is the amount of time that the task was taking, including the queue time, before it could execute. So I find that interesting, to be able to see if we had some sort of backlog or something like that. How long was that backlog? Because the backlog could indicate that we really were suffering on the I/O end. So that's my summary for IOstat, sort of as I explained it. There's a few other things that are really interesting in there, and I think Domus's blog post is the best one to learn how to read IOstat. So now let me apply some context from IOstat, and here's a graph that I produced just a week or two ago when I had a customer problem. And here I graphed how many writes we were doing per second, or how many write sectors per second, what the average amount of wait was, and what the service time was. The service time barely shows up. The writes are kind of not 100% flat, but they aren't always. And I noticed that I had these sharp awaits showing up all the time. And then I realized it was a network-mounted block device, and there was some other sort of contention. So that was my moment of truth, and this just shows you how these tools can help you diagnose and start formulating a theory.
When you have something like a dead RAID drive,
Yep.
you know, if you're doing like, you know, RAID 5 or whatever, does that show up? How does that show up in IOstat, or doesn't it?
Interesting. It would probably show that you have a much larger amount of time that it takes to service the request.
Yeah,
that would be.
That's what I've seen, but I was just wondering if there was actually a like indication, because it's hard to say. Okay, well, how long should these requests take?
Sure.
You know what I mean? It doesn't really show you that. So I guess it just doesn't necessarily show you anything different. So.
Yeah, I mean, if I'm using a battery-backed write cache, the service time should normally be lightning fast, because once it touches the cache and the battery-backed write cache and just says, okay, I've taken that write, then that's probably, it's going to exit this command and I'm not going to see it. Okay, and then the next one that I use, any questions on that? IOstat? No. The next one that I use is a command called top. And top's an old friend. I think we've all seen it. This is kind of similar to these other tools previously. I just use this to be able to give me a current set of events of what's happening. And this is actually the OS X version of it. It's pretty inconsistent between operating systems, but I just like to see what shows up at the top of the list as my explanation of what might be the cause of things that are showing up in VMstat. Here I'm seeing things by process. In the VMstat and the IOstat that I'm showing, I'm getting an aggregated view. So occasionally what I'll do is I'll look at VMstat and I'll look at IOstat. I'll think, MySQL's a problem. Okay, now I'm going to start looking at MySQL. But one step before I do, I use this command, and occasionally I see that they've got something like Apache running. And I'm like, it's not a dedicated database server.
Or like
my theory is not
Spam
that.
Assassin.
Spam Assassin?
There were people running like IMAP email, and you see like Spam D, and like, aha, you're using this
Yeah.
email server too.
And then you've got a social problem on your hands, and that's going to fix your problems. You have to dedicated database servers, please.
Can I ask a quick question? Is the idle that's presented in the top the same as that which is presented in the IOStat?
I think it is. I mean, it depends on the operating system implementation, but my assumption has always been that yes, it is. Yeah. So top's kind of the same as my other tools, but I use it for process stuff. A little bit different across operating systems. Didn't explain too much into that other than it's interactive. And if you like top, you might like this one, HTOP. It's pretty cool. I only just got introduced to it, but here you can see a little bit of a graphical drawing display and some of that other information all in one.
It's even more interactive.
It's even more interactive. So now, having said that, what's the point of all this? First you learn how to read, then you learn how to guess. You have to find the bottleneck, then you have to start making some sort of assumption what caused the bottleneck. And that's the bit that's not the straightforward bit. So here's my poll. What might cause high CPU usage in MySQL? Any thoughts?
Lots of queries.
Lots of queries, absolutely. That might be leading to some sort of context switching. We're attempting more concurrency than we could possibly do.
Or one really large query.
One really large query, possibly. Anything else? Everything. We're trying to figure out a strategy. We know we have high CPU usage. What do we think could cause it? So we can start trying to fix that problem.
Joins, subqueries.
Some very complex joins and subqueries, yep. Here's my theory, and this is not necessarily correct. This is what I just thought of when I was trying to think, how do I solve this problem? Thread thrashing, or heavy context switching, attempting to do too many things at once. Lock handling functions and storage engines with more fine-grained granularity. Any sorts of things like row-level locking, some of InnoDB's internal working things, they can take a little bit of CPU. Sorts in memory, and this is a random list. If I'm sorting a lot of data and it's all in memory, I'm just testing my memory bandwidth and my CPU to be able to do that. And if I do enough of that concurrently, I might run into a problem. Temporary table and working memory, same sort of theory. And maybe encryption functions, they might take CPU. Or maybe doing math in the database, something like that. That's my best guess. And this is where I'd attack this problem and say, any queries that look like they're suspicious of causing CPU usage, let's try and fix them. Start with an idea, then look for information to support that idea. And I didn't realize that didn't show up there. So, poll number 2. What causes heavy disk usage? Full table scans? Yep, if they're not coming out of a cache, then that's absolutely true.
Temp table's too big for memory.
Temp table's too big for memory?
Excessive writes, just lots and lots of writes.
Excessive writes?
Oh,
Badly
the
configured caches.
general log.
Yeah, if they can't hit fast and cache, general log. Yeah, I actually didn't summarize those ones. I had another answer. Anything that writes to disk. So this is interesting because reads can, in like an OLTP, if that's my assumption, they can always come from some sort of cache, but it's the writes are the tricky ones sometimes because there's the letter D in ACID, where we have to have that durability aspect. But then I put an asterisk because I decided that this was too simple an answer, and it's much harder to answer than that. So if you have a healthy RAID controller with a battery-backed write cache, sometimes the writes are actually pretty easy to solve. And then it becomes the reads that are the problem, because the reads can be random. And so maybe we might look for that IO stat to be able to see what the average A weight is and service time and things like that. Yeah, and the writes just go to this battery-backed write cache, and then they just complete whenever. So that's what I thought from there. And then I thought, that's not really that good anyway. You have to further clarify this. And I don't always care necessarily how much writing to disk I'm doing. I care how much writing to disk I'm doing now, because I'm worried about that sort of everything happening at once thing, which is why watching that IO stat under performance is really important. So I might start looking at things that just inherently aren't going to scale if they're touching the disk. And a couple of good examples were things like temporary tables and sorting on disk. I find those ones notoriously evil.
Just to mention another tool, fantastic tool, relatively more known to work. I forget which newer kernel it works with, but doesn't work with all. Is something called IO top,
IOTop.
which will show you which programs are writing are doing IO at the moment. It's like top, and it shows it. It will sort and according to percentage, but it'll show you who's doing the writes into which files.
That's very cool.
Yes,
That's very cool.
relatively new.
Cool. So then, how I do this then is I don't use IOTop, but I probably should be. Is I look for some things in MySQL that I know that are big offenders, and this is my best technique I've used so far. I use a program called Mex. There's two versions of it, one in Perl, one in Shell, and this just looks at show global status and shows me the information for now, and then sort of 10-second averages. I look to see how many temporary tables I'm creating on disk per 10 seconds. And sometimes that information will correlate to my IO stat. Then hopefully I can slow query log these and then start working from there to be able to further improve. So another poll, what do we do when free shows that there are no file system caches left available? File system caches, important for? My ISAM tables. Yeah. So my best strategy that I have on this probably makes sense. Reduce. Find out where I can reduce my memory usage. And my own strategy, not to say that it's the best one, is that I've tended to attack the per session buffers first. Because I've noticed that they can add up quickly if you have a lot of connections. And a lot of people think that, right, my sort buffer or my temporary table of 32 meg was pretty good, let's make it 128 meg. You know, and then there's this finite range where you don't want any particular one session to have the ability to denial of service other sessions. So as a policy, I'm just aggressive on session buffers first, not to say that that's the best one. There's lots of places for that. And sometimes using some tools to be able to look at MySQL's configuration file. Like there's a thing called MySQL Tuning Primer. They can tell you where to start. Inverse question. What do we do when free reports that you have lots of free memory? Allocated. Sure. That makes sense. Any strategies where you might put it towards first? Yeah, and that's generally what I do. I just spend it. So these are two different problems, but they're both important, I think. Yeah, I mean, if it looks like we've got a lot of temporary tables that are missing that sort of cutoff point, and they're going to disk, maybe we can increase the size of that buffer. But
Let me ask you the first problem in this final one.
it can be. Yeah, definitely. Like if I look at, probably outside the scope of this a little bit, but if I look at show NODB status, and I'm already getting a very poor hit rate on my buffer pool, I don't really want to decrease the amount of NODB buffer size for that, because then I'm going to have worse performance. So sometimes you can do it, sometimes you can't. Often my strategy when I log into customer systems is I try and find a solution now. So there's like a lead time sometimes of a couple of days to install memory and find a time for downtime.
Do you see a lot of free servers?
Yeah, sometimes. And that's an issue as well on free. Sometimes you'll see that it hasn't even allocated that memory towards file system caches because it's a 32-bit OS, a 64-bit system. And that's a diagnostic that I find happens probably 1 out of 10 systems I log into. It's pretty scary how frequent it is. Cool. So let me summarize down and finish up. Really have fun in chasing in bottlenecks. I don't want to simplify the task because it's actually a hard one, and I hope this just provides an introduction to how I use these tools in sort of fueling my methodology to keep searching. And if you have trouble, if you want help, I'm sitting at the Picona booth, and I'll happily interpret that information for you. So, thanks very much.